going to talk about, are you prepared for deep learning? I want to say that I thought that I would be somewhat off topic for all of you today. I've been sitting here and really drinking in a lot of the discussion here, and I think there's a lot of overlap with what I'm about to say. And I would love to collaborate with people here. And in particular, I think that one of the clienteles that this group has a lot of value for are the data science teams in the large corporations. I think there's a big disconnect between the people that are coming out, usually fairly young, fairly new, with some very valuable skills, but they really don't understand corporate IT. They don't understand the whole value of data structuring and the like. I think there's ways of adapting the methodologies that we've been talking about specifically to cater to the data science group, okay? And as opposed to catering to the data warehouse group type of thing. I'd love to collaborate on that. I'll shut up on that and bring it up during the Q&A. So, I'm on a mission. My mission is the management challenges of deep learning, or shall we say deep learning enabled systems. Now what I really mean about that, and I want to use more technical terms than glossy terms, I want to avoid artificial intelligence and deep learning and terms like that. Artificial neural networks have been around for 20, 30 years or so, but in the last 5 years there's been some breakthroughs in research that have made astounding advances, okay? And we see some of them in the headlines. Most of them are labeled with the AM label on it, or the AI label on it. But underneath is neural networks. And so this is what I'm zeroing in on this specific technology. I don't want to evangelize it. There's a lot of exciting, good things about it, but it's also scary. It's going to also be challenging. And I think most people that get into it are going to have their butts bit, okay, to put it bluntly. And I'm looking at IT infrastructure at scale, okay? We're not doing little isolated one-off sorts of things, but major changes in the way the business behaves with their customers and the like. So I want you to imagine that you're an IT manager who's been given the responsibility for an analytical system that's been enabled by neural networks. What does that mean? How do you prepare for it? What are the skills? How much technical knowledge do you need? Do you apply the same old IT paradigms and procedures for project administration and business objectives and things like that? Or is there something different here? My hypothesis is that there are unique challenges here. And I want to prove or disprove that hypothesis, okay? And so I'm putting it out there and saying, okay, I think there's some unique things. Because if this manager proceeds ahead and sort of does the same old IT thing, there ain't going to be the communication that's necessary in that area. So this is sort of my target. Put that in the back of your mind. My outline is going to talk about new paradigms that are popping up in the area here. I've written a paper on new paradigms. There's a link that I'll share with you to that. Also, and then new values. So I cherry-picked some stuff out of these two papers that have been written in the last few things, and then give you some suggestions on one slide on preparation. The first thing is the paradigm shift from describing known data, which is really constitutes like 80% of business intelligence nowadays. You know, conventional machine learning is starting to change this gradually, okay? But really what you're focusing on with the whole neural network technology is generalizing beyond known data. We all seen this in trend lines in terms of, what's the sales report. We do it intuitively. We do a scatter plot and we sort of imaginarily draw the line. Well, next sales will be 20% higher, simply because that's where the points are going. But how do you infer, and I like the phrase, smartly guess what sales will be next month? Now, when you got two features here, two variables, okay, you can sort of look visually. But how do you know if there's other factors that haven't been factored in here that are going to change that, okay? And that's what the neural networks come in. So how do you smartly guess? Why did it happen? What will happen? What should happen? Are kind of the traditional questions there. Also, there's a lot of talk about machines learn, okay? Machines learn by example, but humans teach machines. So another paradigm shift here is that when you're dealing with neural networks, particularly from a management point of view, your responsibility is on teaching the machine. And what you teach that machine is what it's going to model. Okay? And what it models is the way your systems that are enabled by it are going to behave. So a good analogy that I think is grade school. As a manager, you're responsible for the examples that you give to the kids there. And your model in the beginning is definitely a kid. Doesn't understand your business at all. In fact, when you start training a neural network, okay, you start with pretty much random numbers in the weights, okay? You start with nothingness. And it's only the examples that give it any type of meaning. So the whole thing is teaching by examples. Good examples mean smart guesses. That's what your objective is. So that's another thing. It's not defining a priori what the logic should be. It's defining a priori what good examples are and feeding those to the training of your models. Another paradigm shift is that we're seeing, in many cases, the shift or the exceeding of human level performance. And what that really means, I just completed a 6-month specialization in deep learning, and I got to the end of this and I kind of looked through the material, and we spent about a month talking about what does it mean to exceed human level performance. And the instructor, Andrew Ng from Stanford, I think appropriately set our focus on that and really dealt with it from a practitioner's point of view, not just theoretical, on what does that mean when you do that from a technical point of view. I'd like to extend some of his thinking in terms of what it means from a practical point of view. He asserted, and I think some other researchers have asserted, that if you have a specific task that requires 5 to 10 seconds of human thought, there's a good chance, and we have lots of examples of it, there's a good chance we can exceed human level performance for that task. So it's not just deferring whether dogs versus cats in image processing is sort of shall we say, the canonical example where it was diapers and beer in the machine learning era. It's now called, we can distinguish between dogs and cats, and elephants and the giraffes, and 20,000 other categories now. Let me give you an example that tries to give it at a more subjective level. Let's say, I'm a father, I have a son. He goes to high school, he goes to college, he goes to graduate school, he gets a job, has a family, starting a family, he comes home at the holidays. I say, son, how's work going for you? Okay? And son says, well, Dad, I'm really doing some exciting things for my company. I'm trying to design this oxyradical that attaches to this enzyme that will try to attack pancreatic cancer cells because of certain inhibiting of certain chemicals out here. Dad says, that's kind of nice. I mowed the lawn yesterday. You know, it's that kind of conversation, folks. You know, you get one of these things cranked. If you're successful at it, this is the conversation that you're going to have with the system that you're dealing with there. Here's another way of looking at it. Horizontal is the amount of labeled examples that you have, okay? And I put down here 100, 1,000, million, billion, okay? Typically in conventional machine learning, you have 100 to 1,000 types of examples, and you train your model on that, and you know, your model passes the validation test on the test data and so forth, and you put it out in production. Okay? You might go back and retrain it, you know, maybe monthly or something like that. But you're dealing with loads amount of data. And then the vertical scale, should explain that, is your model performance. At the bottom of that, you're flipping a coin. You're essentially saying, is this a dog or cat? Well, we'll flip a coin. Oh, well, it's a cat, you know, because it's heads. At the top level, you're hitting it every time. Well, because your data has certain limitations and noise in it and this sort of thing, you'll never hit 100%, okay? But then somewhere below that is human level performance. If you show this, you know, this image of a dog or cat to someone within 5 seconds, they could say, oh, that's a cat type of decision. And the ImageNet is essentially the model that is currently being used and is publicly available, contains 14 million examples to train that model, and it's divided into 20,000 different categories. So the dogs and cats have a lot of friends. So what do you take away from this? Well, first, at the low end here, when you're dealing with hundreds of examples, any analytic will do just as good as any other, okay? So there's no advantage to neural networks and the additional complexity that they bring there. On the other hand, if you're dealing with high amounts of data, and we're talking about millions to billions of different examples of things, then it really has some power. And there is a definite difference in what you can do with the machine learning algorithms that are out there, which are a lot simpler, okay, a lot quicker to run and things like that. But then it gets interesting as you get near the human level performance. Remember the conversation between father and son. So the challenge here is, how do you get human intuition blended with machine intelligence? Okay, it's going to happen, at least in the specific cases there. And there's a lot of different variations here. What I'm trying to wave the flag about is that a lot of people are going for number 2 up there. You let the machine automate it and you eliminate the human from the loop. What I'm saying is that really this is extremely important here. The takeaway is, how do you design the human back into the loop there? Here's two more paradigm shifts here. One is the black box. If you ask somebody about, you know, what are some practical examples from using neural networks and what are their disadvantages, black box pops up as number 1 or 2. In other words, all you got are literally thousands, if not millions, of numbers in there. Trying to interpret why you came up with that prediction is very difficult. There's a lot of good research going on right now in this particular area, but we're still a long ways from it. So it's a black box. So what do you do about it? And I took a view in this last paper about managing to the black box. So if you're the manager, number 1, magic happens, okay? The data science team that you've spent a lot of dollars on their salaries, okay, are responsible for the magic. Let them do their stuff. But manage to the black box by first looking at the outputs, What are the outputs that you expect, and how does that drive business value? And then looking at the inputs, particularly the examples. Are you giving them good examples? Are they biased examples? And are there sufficient number of examples, and so forth? Thank you very much. And I move along here. And then it's not the usual project. It's cultivating a farm, and I'm going to move a little quicker here. Now, switching gears, new values. I spent some time trying to think to, now what's the value of analytics? And if you do a literature survey, what you see is insights, more value, more insights, more value, etc. Insights mean nothing unless it changes the behavior of the organization, okay? So how do you use analytics to change the, so I went back to the 1950s. Peter Drucker had this pithy statement here. Efficiency is doing things right. Efficiency is doing the right things. Well, IT has concentrated on efficiency, reliability, et cetera. Analytics, we have a chance here of focusing on effectiveness, okay? The effectiveness of doing the right things. So what are the right things? In this thing, intelligent effectiveness for analytics is customizing that task to meet the needs of a specific situation. And what I mean by a task is the million tasks that you're processing every day with your customers, your suppliers, shipping products, etc. Each of those tasks, can you do it in a better way than before? Can you customize it, okay? We're starting to have that kind of ability here. So if we can pin business value on that intelligent effectiveness, then I think you've got an argument that will do well in the boardroom and with executives, all the way down to the people that have to implement it. I think the human intuition loses its mojo at a million unique things. Now that's a very subjective type of number. I mean, it could be 1,000 unique things, but unique things mean, are you dealing with it uniquely, okay? It's not a million things that you deal with as 10 different things. You segment your customers into 23 different categories where you're dealing with 23 unique things. I'm talking about dealing things with a million unique things, and that's a mutt, okay? I think that's a unit of measurement that if you're dealing with things that are a mutt, then you're starting to get into an area that business value drives the use of neural networks. Here is another way I look at the value chain. These are the things that need to be sort of put together. Kind of echoes on the corporate information factory stuff from 20 years ago, Inman and Emhoff days. But it follows a lot of the flow here. I tweaked it a little bit to infer, generalize and infer, but the point is that you go from data to action. The action is operationalizing so that you're changing the behavior of business processes. Now you can have lots of insights along the way, but unless you have changes in the action, you won't be there. The other kind of interesting twist to the whole neural network area is that it's not just fitting into this supervised learning paradigm. Okay, there are now lots of different variations. One of these variations is called reinforced learning, where you do something, you find its effects, and then you feed it back as new examples. So the ultimate goal here is to say every transaction, all those millions a day, each of those transactions go back and tweak the weights in your model for every transaction continuously. And this is called learning logic, which is the next slide. Essentially, we're going through various shifts in the way we think about software. And we have been with static logic, and I remember the COBOL days. I remember that, and now, you know, it was Java, and now we're more Python, you know, and so forth. If you're non-volatile, I mean, each of these areas of logic are applicable. It depends on your business environment. Is it volatile, and is it simple or complex? Okay, and when you get to a volatile, complex thing, then you're really into continuous learning, which has been labeled in some of the literature as software 2.0. Own the responsibility. This is my, shall we say, my lecture to you, okay? I think there are going to be some unique challenges. I think there's a lot of positive things, but I think there's also a lot of potential negative things. Some people have characterized neural networks as the new electricity, and the way it has changed society over the last century. I think that's a positive way of characterizing it. Other people have characterized it as nuclear energy, and which has done lots of benefits for society, but also has some very negative consequences also. And so we're kind of in searching out what are the long-term impacts of this kind of technology. But if we're looking at it from that IT manager that I showed you at the beginning there, then own the responsibility, and long-term, you're going to be managing towards, how do you manage superintelligence? How do you have that father-son conversation where the son now is the neural network system that you've implemented?
Questions?
Questions, right over here. Go.
So I'd like you to talk about what you insinuated to earlier about the difference between data for the, I think you said for the data scientist versus the warehouse.
Good. That's one area I wanted to, I used the term example very purposely because I'm an old SQL guy. Okay, I used to teach classes for Cod and Date associates and taught the relational data model all over the world for about 2 years. That was a kick. So I mean, in instance, thinking tabular, an instance has been kind of the or a row on a tabular tale has been kind of what people are thinking examples have been to train these models, and certainly conventional machine learning is that way. But what we're seeing in the neural networks is that you can throw a lot of stuff at it. Okay, a lot of junk. You can throw images, you can throw sounds, you can throw melodies, you can throw you know, as examples, okay, along with tabular data, okay, and I think the getting back to the remark I made earlier on how this community can help the data scientists is coming up with the right design of the data design for what an example is that has a very complex mixture of things. The other shift am I answering your question or not?
By an example, you mean a piece of information that you can use to train a model. Is that?
I would define an example as characterizing the situation in which you're taking the action adequately. Now, if you're dealing with, I mean, some of the early unstructured data we had is clickstream. It's when somebody clicks on a web page, you know, and you get that big, long, complex, and the big thing was how do you tear down the text in that clickstream, okay? That was an example back 10 years ago now. An example nowadays should be not just, you know, what happened at that click, but all the other context of it, in other words, who's the customer and what was the product on the web page, and was it on discount and so forth. In other words, what's the whole context on that click, okay? That's a pretty big, messy chunk of information. That's one example.
Is maybe, I just read that Tesla is now asking their own employees to drive in cars and get all the information to learn how to pilot. Is that what you mean with the example? Because having complex situations.
Yeah, that's a good example. Autonomous vehicles are a great experiment that we can benefit from in a lot of other areas. But think of it, okay, so you are actually generating training data for Tesla every time you put it in auto mode, and it records everything and then sends it up, and it learns from that. Everyone benefits in this sort of thing from that, but what's an example in that thing? And that's a really good that's a good data design question. Is it the entire experience of 23 minutes? Or is it every second? Or is it a sequence of seconds? Is it a sequence of milliseconds? Is it, what are you trying to train the model for? So here, the responsibility is trying to say, okay, what kinds of prediction, what's a good example in the sense of what the model is trying to predict, okay? So I can see the same, collect, all the data from a 23-hour drive by one of Tesla's employees type of thing, and I can see that same set of data being used for different sets of examples,
And what about unlearning?
What's that?
Unlearning.
Unlearning?
Sometimes you can, learn deep learning and algorithm training to do something. Wait a minute, this is not the direction you want to go.
Right. Actually, there's a whole body of research in bias in learning. There's natural language processing. They've done a lot of word analogies where you have king, queen, doctor, question mark. And guess what the question mark usually comes up with? Female, okay, or nurse, okay, because the word analogy has keyed in on the gender thing, and therefore all nurses are female. Okay, just like all queens are female. Okay, now that's that's another one of these beer diaper types of analogies in the neural network area. So debiasing is now a research area that's trying to have models unlearn sort of thing. You have a question?
Yeah. So,
Shane. Shane.
Yeah, so AI for me, kind of at the moment, is scaring me in terms of what happened with big data, in terms of the marketing and the fluff around it. And if you talk to some of the large analytics software companies, I think we mentioned it before, we've had neural networks for many years. We've had machine learning for many years.
Yeah.
Are you seeing that AI is just now a brand of machine learning where we add other data types in terms of images and voice and sounds? Or is it a new way of saying we use machine learning to a point and then AI is when it starts learning itself based on the things we've taught it? Or is it actually something else? What's your view?
I think it's a little complicated here, and I think this is a really good question. I think there is a difference between the way what we consider now to be machine learning and shall we say this kind of new technology that has emerged from machine learning, which is the neural networks. Now, I don't want to talk AI type stuff because it's becoming now a kind of a meaningless label as far as I'm concerned, especially when used by vendors.
Which is the
Okay.
answer.
Yeah, okay.
One
So,
thing about it is
right,
being
right.
kind of hijacked
Okay.
as the new marketing spiel, right?
I would go back to that one curve that showed the difference. As you increase the amount of data that you can use for training, good examples, okay? The neural networks gives you the ability to really absorb the complexity and do a better job on inferring or smartly guessing based on that data. Many times, I mean, we're talking 10 times or more than the conventional. The conventional has fixed logic in the way it does it. I mean, a logistic regression is actually pretty simple. And support vector machines and you know, those algorithms are not going to go away. They really have a lot of use to them, okay? But they're not going to compete with a 120 level hidden level model in terms of being able to absorb the complexity and spit it back in useful predictions and stuff.
So if I play
So,
back, then when we talked about big data originally,
yeah,
we had a constraint with some of the relational databases when the volume of data was too large, when we were trying to do image processing of voice and they couldn't absorb that type of technology. What I think you just told me is machine learning is kind of back to the relational world, and now we've got a lot more volume to model and we've got a lot more variability in terms of video and voice. So we've got the V problem now for how we do analytics.
certainly.
We are getting the word hijack just like it did with big data.
Okay, let me agree with you that we certainly have a lot more variety of the V's, or we can consume more of the variety with the V's. We don't have to distill them. I think, the other principle is here that feature engineering actually it has been and still is a big component of machine learning, is that you use human intuition to pick the features that you use, okay? In neural networks, you just kind of throw the stuff at it, okay? So which means you can have a much wider variety of initial attributes, I don't want to say feature, or you don't have to engineer the features right up front. You can actually discover them over time, and they may change depending on what your examples are like. So
I liken it to when we loaded data into a relational database, we had to choose which fields to load.
exactly.
When the magic lake turned up, we loaded it all and hoped like hell somebody could use it.
Right.
So,
You know, the bottom line is the company that owns the data wins, okay? And because of IoT in particular, it's driving big data so that more and more of capturing that situation, okay? All the attributes of the situation become more likely. So it's, yeah, as I said, it's exciting and it's scary. So, any other?
One last question.
One last question? Come on. John, in the back. Question.
I don't disagree with your statement about AI losing its meaning, but I think you're being too critical of that because that's the true value. The models are going to be the things that identify the problems, and the AI is going to be the thing that's going to affect the change.
Let me say.
So, I mean, I don't disagree with what you're saying, but I think you're being too harsh.
I'm not being harsh, I'm being academic. Okay? It's, you are seeing 13 years of academician showing forth, and
I mean, I'm wholeheartedly like, you know, how did we get from predictive analytics to all of a sudden it's AI? Like, some marketing dude just decided, let me jump from here to here to here to here.
right.
But that the action of AI is going to be how it's going to take place, which is why I refer to
Again, you know, what is the action of AI? I mean, I think the sci-fi movies have a better description of the action of AI.
It would be autonomous cars would be an example. It would be automated trading would be an example.
Look, if you talk to somebody who's actually doing the stuff in autonomous cars, they don't want to talk about AI. They want to talk about the neural network that's processing the data. okay?
You can ask for my comments if you don't know.
Oh, no, your comments are great. That's a great way to end. So, thank you very much.